In today's video, we'll be learning about the Wheatstone Bridge Principle. The diagram given below is a configuration of the Wheatstone Bridge. Here, the Wheatstone Bridge is powered by a cell of EMF value E, and R1, R2 and R3 are resistors of non-value, while Rx is an unknown resistor. If the current that is flowing across the galvanometer is Ig, according to the Wheatstone principle, if Ig is equal to 0, then R1 over R2 is equal to R3 over Rx. Since Rx is the unknown value, we can subject Rx and then we will get the equation Rx is equal to R3 into R2 divided by R1. Usually, a Wheatstone bridge is used to find the resistance of an unknown resistor. Now let's prove the Wheatstone bridge principle. Here, let's assume that Ig is equal to 0 ampere. Then let's mark the current. We have I here, and then the current across R1 will be I1, and since Ig is 0 ampere, the current across R3 will be I1, and let's say the current across R2 resistor is I2, then the current through the Rx resistor will also be I2. Now if we mark the voltages, let's say this point is A, and this point is B, and this point is C, and this point is D. Since Ig is equal to A, we can say that Vb is equal to Vd. Therefore, if you apply the Ohm's law, V equals IR to R1 resistor, we get A minus Vb is equal to I1 times R1. That is the first equation. And V equals IR to R2. We get Va minus Vd, that is equal to I2 times R2. That is the second equation. Since Vb is equal to Vd, we can say that 1 is equal to 2. Therefore, I1 R1 is equal to I2 R2. Let's name this equation as A. Next, let's apply V equals IR from A to C, this path. Then we get Va minus Vc is equal to I1 times R1 plus R3. That is the third equation. And if we apply V equals IR from A to C in this path, we get Va minus Vc is equal to I2 R2 plus Rx. That is the fourth equation. And then we can say that 3 is equal to 4. That is I1 R1 plus R3 is equal to I2 R2 plus Rx. That is the equation B. Then if we divide equation B by equation A, we get I1 times R1 plus R3 is equal to I2 R2 plus Rx divided by I1 times R1 and I2 times R2. Then I1 will get cancelled off, and then I2 will get cancelled off, And then if we simplify this, we get 1 plus R3 plus R1 is equal to 1 plus R2x plus R2. Therefore, we can say that R3 over R1 is equal to Rx over R2. And if we subject Rx, we get R2 times R3 divided by R1. Let's move on to an example. Here, the current flow across the galvanometer is G is 0, and we have to find R1. Now, since the current flow across the galvanometer is 0, this is a Wheatstone bridge configuration. Therefore, 70 divided by 140 ohms is equal to 80 divided by R1. Therefore, R1 is equal to 80 times 140 divided by 70. That will give us R1 is equal to 160 ohms. Now we can simplify this circuit like this. We have 70 here, and we have 80 here, and we have 140 here, and we have 160 here. This is point A and this is point B. This is the second part and this is the first part. Now if we get the equivalent resistance of 70 and 80, since both of these are in series to one another, we will get the equivalent 70 plus 80, that is 150 ohms, and 140 and 160 are in series to one another. So we get 140 plus 160, that will be 300 ohms. And then we can further simplify this. 150 and 300. This is A and this is point B. Then RAB is equal to 1 over 300 plus 1 over 150. If we get the common denominator, we get 3 over 300. Then RAB will be 100 ohms. Okay, now in this problem, we have to find the equivalence resistance between A and B. First of all, let's mark the voltages. Now, if the voltage at this point is A, at this point it will be A. And here it will be B, and at this point it will be B. And also here if it is C, at this point it will be C. And at this point if it is D, here it is also D. Now we can rearrange this circuit like this. Now if this is point A, and from point A to point B we have a resistor that is 6 ohms. From B to D we have a 12 ohm resistor. This point will be D. And from A to C we have another resistor that is 3 ohms. And from C to D we have the 6 ohm resistor, this one. And from B to C we have the 8 ohm resistor. Now if we consider this circuit, if we get the ratio between these two resistors and these two resistors, that will be 6 divided by 3 is equal to 12 divided by 3. Now if we get the ratio between these two resistors and these two resistors, we get 6 ohms divided by 3 ohms is equal to 12 ohm divided by 6 ohm. So both of these ratios will give us half. Therefore, we can verify that this is a Wheatstone bridge. Therefore, VB is equal to VC. As a result, there is no current flow across the 8 ohm resistor. Therefore, we can just remove it. And if we simplify this, 6 and 12 resistors are in series, and 3 and 6 resistors are in series. Therefore, we get 12 plus 6, and here we get 3 plus 6. That will give us an 18 ohm resistor and 9 ohm resistor. Now if you get the resistance, 1 over RAB is equal to 1 over 18 plus 1 over 9. And then we get 1 over RAB is equal to 3 over 18, that is 1 over 6. Therefore, RAB is equal to 6 ohms.